Welcome to my 10 subscriber special video. Many thanks to all of you who have decided to subscribe to my channel. In this video, I will be solving 100 integrals going from the easier ones to the harder ones, respectful of the order in which they are given in the book. There will also be another video like this one in which I will solve another 100 integrals. This can be the mathematics equivalent of David Goggins doing 4030 pull-ups in 17 hours, except that nearly every college student taking a calculus course does this while studying at some point. So without further delay, let's go to the integrals. The first integral is of 2x dx. This is equal to 2 times an integral of x dx, which is equal to 2 times x squared divided by 2 plus c, which is equal to x squared plus c. And of course, area in which this integral is defined is in an entire set R of real numbers. The second integral on our list is x squared dx, which is equal to x cubed divided by 3 plus c, and of course the area in which this integral is defined is an entire set R of real numbers. Next integral is an integral of negative 4t cubed dt. This is equal to negative 4 times an integral of t cubed dt, which is equal to negative 4 times t to the fourth power divided by 4 plus c, which is equal to negative t to the fourth power plus c. Area in which this integral is defined is again the entire set R of real numbers. The next integral is an integral of square root x dx. Now, since x is under the square root, we see that area in which this integral has to be defined in is for all x's which are larger or equal to 0. So this is then equal to an integral of x to the power 1/2 dx, and then this is equal to x to the power 1/2 plus 1 divided by 1/2 plus 1 plus c. And at the end, this is equal to 2/3 a square root of x cubed plus c. The next integral which we have to solve is an integral of dx divided by x cubed. We have x cubed in the denominator, so that means that x has to be different than 0. So our area in which this integral is defined is from negative infinity to 0, union from 0 to plus infinity, where 0 is not included in this interval. This is equal to an integral of x to the power negative 3 dx, and that is going to give us x to the power minus 3 plus 1 divided by minus 3 plus 1 plus c, which is equal to x to the power negative 2 divided by negative 2 plus c, which is equal to negative 1 divided by 2x squared plus c. The next integral which we have to solve is an integral of 4 dx divided by x to the fifth power. Again, we are dividing by x to the fifth power, so x has to be different than 0, which makes our area in which the integral is defined the set of real numbers when we exclude 0 from it. This is then equal to 4 times an integral of x to the power minus 5 dx, which is equal to 4 times x to the power minus 5 plus 1 divided by minus 5 plus 1 plus c. This is then equal to 4 times x to the power negative 4 divided by negative 4 plus c, which is equal to negative 1 divided by x to the fourth power plus c. The next integral which we have to solve is an integral of x times cubic root of x dx. Now when we have the square root of x, x has to be a number which is larger or equal to 0. The cubic root doesn't have that problem, so the area of definition of this integral is an entire set of real numbers. So this is then equal to x times x to the power 1/3 dx, and that is equal to an integral to the power x 1 plus 1/3, which is going to give us 4/3 dx. That is equal to x to the power 4 divided by 3 plus 1 divided by 4 divided by 3 plus 1 plus c, which is going then to give us x to the power 7 divided by 3 divided by 7 divided by 3 plus c, which is equal to 3 divided by 7 cubic root of x to the power 7 plus c. Problem number 8 is an integral of dx divided by cubic root of x. Since we are dividing by the cubic root of x, x has to be different than 0, so the area in which this integral is defined is set of all real numbers except 0. This is then equal to an integral x to the power of negative 1/3 dx. This is then equal to x to the power negative 1/3 plus 1 divided by negative 1/3 plus 1 plus c, which is going to give us x to the power 2/3 divided by 2/3 plus c, which is 3/2 cubic root of x squared plus c. The next problem which we have is an integral of x minus 2 divided by x cubed dx. Well, x cubed is in the denominator, so that means that x has to be different than 0. And that is going to mean that our area in which this integral is defined is set of all real numbers except 0. This is then equal to an integral of x divided by x cubed dx minus 2 integrals of 1 divided by x cubed dx. This is then equal to an integral of dx divided by x squared minus 2 integrals of 1 divided by x cubed dx. This is then equal to an integral of x to the power negative 2 dx minus 2 integrals of x to the power negative 3 dx, which is going to give us x to the power minus 2 plus 1 divided by minus 2 plus 1 minus 2 integrals of x to the power minus 3 plus 1 divided by minus 3 plus 1 plus c. This is equal to negative 1 divided by x minus 2. 2 and 2 are going to cancel out, so we are left with plus 1 divided by x squared plus c. And the next problem, number 10, is an integral of x squared plus 2x plus 1 divided by x dx. Well, that means that area in which this integral is defined is for all x's which are different than 0, and that is going to give us the set R except the number 0. This is then equal to an integral of x squared dx plus 2 integrals of x dx plus an integral of 1 over x dx. This is then equal to x cubed divided by 3 plus 2x squared divided by 2 plus ln of absolute value of x plus c, which is equal to 1/3 of x cubed plus x squared plus ln of x under the absolute value plus c. Number 11 is integral of 5x cubed minus 4x squared minus 3x plus 5 dx. This integral is defined on the set of real numbers. This is equal to 5 integrals of x cubed dx minus 4 integrals of x squared dx minus 3 integrals of x dx plus 5 integrals of dx. This is equal to 5 times x to the fourth power divided by 4 minus 4 times x cubed divided by 3 minus 3x squared divided by 2 plus 5x plus an arbitrary real number c. Number 12 on our list is an integral of square root of x times the square root of x times the square root of x dx. Since x is under the square root, we see that x has to be larger or equal to 0. So area in which our integral is defined is from 0 to plus infinity, where 0 is included in the domain. This is then equal to, an integral of x parenthesis x parenthesis x to the power 1/2, close parenthesis power 1/2, and closed parenthesis power 1/2 dx. This is then equal to an integral of x to the power 1/2 times x to the power 1/2 times 1/2. This is 1 divided by 4 times x to the power of 1/2 times 1/2 times 1/2, which is 1 divided by 8 dx. This is then integral of x to the power 1/2 plus 1/4 plus 1/8 dx. This is then equal to an integral of x, 8 in the denominator, 4 plus 2 plus 1 in the numerator dx, which is an integral of x, 6, 7 divided by 8 dx, which is then equal to x to the power of 7 divided by 8 plus 1 divided by 7 divided by 8 plus 1 plus a constant c, which is equal to x to the power 15 divided by 8 divided by 15 divided by 8 plus c, which is 8 over 15 times an eighth root of x to the power 15 plus c. Integral number 13 on our list is 6x to the power 4 plus 8x to the power 7/2 minus 5x plus 2 divided by x dx. This is equal to integral of 6x to the power 4 divided by x plus 8 integrals of x to the power 7/2 divided by x minus 5 integrals of x divided by x dx plus 2 integrals of dx divided by x. Area in which this integral is defined is for x is different than 0, and since we have x to the power 7/2, that is equal to a square root of x to the power 7. To keep the well-definement of the square root function, x has to be larger or equal to 0 in this case, and finally that is going to give us that x belongs in an interval from 0 to plus infinity, where 0 does not belong in that interval. So our integral is defined in area from 0 to plus infinity, which is an open interval. This is then equal to 6 integrals of x cubed dx, and I have dx's. So x cubed dx plus 8 integrals of x to the power 5 divided by 2 dx minus 5 integrals of dx plus 2 integrals of dx over x, which is 6 times x to the fourth power divided by 4 plus 8 times x to the 5/2 plus 1 divided by 5/2 plus 1 minus 5x plus 2 ln absolute value of x plus c, which is equal to 3/2 x to the fourth power plus 8 times x to the power 7/2 divided by 7/2 minus 5x plus 2 ln of absolute value x plus c, which is equal to 3/2 x to the 4th power plus 8 times 2 divided by 7 times a square root of x to the 7th power minus 5x plus 2 ln of absolute value of x plus c, which is then equal to 3/2 x to the 4th power plus 16 divided by 7 x to the 7th power under the square root minus 5x plus 2 ln's of absolute value f x plus c. The next integral is an integral of x to the 4th power minus a square root of x plus x cubic root of x plus 1 divided by x squared dx. Area in which this integral is defined for all x is larger or equal to 0 because of this square root, and x has to be different than 0 because we have here dividing by x squared. Well, that means that area in which this integral is defined is from 0 to positive infinity, which is an open interval. This is then equal to an integral of x to the 4th power dx minus an integral of x to the power 1/2 dx plus an integral x times x to the power 1 divided by 3 dx plus x to the negative 2 power dx, which is equal to x 5 divided by 5 minus x 1/2 plus 1 divided by 3/2 plus an integral of x to the power 4 divided by 3 dx plus x to the power negative 2 plus 1 divided by negative 2 plus 1 plus c, which is equal to 1/5 of x to the 5th power minus 2/3 of x cubic squared root of x cubed plus x to the 4 divided by 3 plus 1 power divided by 4 divided by 3 plus 1 plus x to the power negative 1 divided by minus 1 plus c, which is equal to 1/5 of x to the 5th power minus 2/3 of a square root of x cubed plus 3 divided by 7 of the 3rd root of x to the 7th power minus 1 divided by x plus c. The 15th integral on our list is an integral from 10x to the 8th power plus 3 divided by x to the 4th power dx. Area in which this integral is defined is for all x is different than 0, so d is equal to r without 0. This is then equal to 10 integrals of x to the 8th power divided by x to the 4th power dx plus 3 integrals of 1 divided by x to the 4th power dx. This is then equal to 10 integrals of x to the 4th power dx plus 3 integrals of x to the power negative 4 dx. This is equal to 10 times x to the 5th power divided by 5 plus 3 integrals of x to the negative 4 x to the negative 3 minus 3 plus c, which is finally going to give us 2x to the 5th power minus 1 divided by x cubed plus c. Number 16 on our list is an integral of x plus 1 in parentheses times x squared minus 3 divided by 3x squared dx. This is then equal to This integral is defined for all x's which are different than 0, so D is a set of real numbers without a 0. This is equal to an integral of x cubed minus 3x plus x squared minus 3 divided by 3x squared dx. This is an integral of x cubed divided by 3x squared dx minus integral of 3x divided by 3x squared dx plus an integral of x squared divided by 3x squared dx minus 3 integral of dx divided by 3x squared, which is equal to 1/3 of an integral x dx minus, these are going to cancel out, 1 over x dx plus 1/3 of dx, these are going to cancel out, minus 3 and 3 are going to cancel out, x to the power minus 2 dx, which is equal to 1/3 x squared divided by 2 minus ln of absolute value of x plus 1/3 x minus x to the power minus 2 plus 1 divided by minus 2 plus 1 plus c, which is equal to 1/6 of x squared minus ln of absolute value of x plus 1/3 of x plus 1 divided by x plus c. Integral number 17 is an integral of x to the 4th power minus square root of x plus x times cubic root of x plus 1 divided by x squared dx. The area in which this integral is defined is for all x's larger or equal to 0 because of this square root, and x has to be different from 0 because here we have division by x squared. Well, that means that x has to be larger than 0. So our area in which the integral is defined is an open interval from 0 to plus infinity. Then our integral is equal to an integral of x to the 4th power dx minus an integral of square root of x dx plus an integral of x times a cubic root of x dx plus an integral of 1 divided by x squared dx. This is then equal to x to the 4th power plus 1 divided by 4 plus 1 minus an integral of x to the power of 1/2 dx plus an integral of x times x to the power of 1/3 dx plus an integral x to the power minus 2 dx, which is equal to x cubed divided by 3, x to the 5th power divided by 5 minus x to the power 1/2 plus 1 divided by 3/2 plus an integral of x to the power 4 divided by 3 dx plus x to the power negative 2 plus 1 divided by negative 2 plus 1 plus c, which is then equal to 1 divided by 5 x to the 5th power minus 2/3 of a square root of x cubed plus x to the power 4/3 plus 1 divided by 3 and 7 minus 1 divided by x plus c, which is then equal to 1 divided by 5x to the 5th power minus 2/3 square root of x cubed plus 3 over 7 cubic root of x to the power of 7 minus 1 divided by x plus c. Integral number 18 is an integral of x minus a square root of x times 1 plus a square root of x divided by a cubic root of x dx. Well, area of the definition of this integral is for all x's which are larger or equal to 0 because of the square root of x, and cubic root of x has to be different from 0, which means that x is different from 0 because we have a division right here. So that means that area in which this integral is defined is for all x's which are inside the interval from 0 to plus infinity, which is an open interval. So this is then equal to an integral of x plus x times the square root of x minus a square root of x minus x divided by a cubic root of x dx. This is then equal to an integral. X and negative x are going to cancel out, and we are left with x square root of x divided by a cubic root of x dx minus an integral of a square root of x divided by a cubic root of x dx, which is equal to an integral of x to the power 1 plus 1/2 minus 1/3 minus an integral, of course dx, x to the power 1/2 minus 1/3 d. This is then equal to an integral of x to the power 6 plus 3 minus 2 divided by 6 dx minus an integral of x to the power 3 minus 2 divided by 6 dx, which is equal to an integral of x to the power 7 divided by 6 dx minus an integral of x to the power 1 divided by 6 dx, which is equal to x to the power 7 divided by 6 plus 1 divided by 7 divided by 6 plus 1 minus x to the power 1/6 plus 1 divided by 1 over 6 plus 1 plus a constant c. This is then equal to x to the power 13 divided by 6 divided by 13 over 6 minus x to the power 7 divided by 6 over 7 over 6 plus c, which is equal to 6 divided by 13, the 6th root of x to the power of 13 minus 6 divided by 7, a 6th root of x to the power 7 plus c. The next integral on our list is an integral of a 1 minus 1 divided by x squared times a square root of x times a square root of x dx. So area in which this integral is defined is for all x's which are different than 0, because we have division by x squared in this term, and x is under a sign of square root, so x has to be larger or equal to 0. That gives us that x has to be larger than 0, and area in which the integral is defined is from 0 to positive infinity. This integral then becomes an integral for 1 minus 1 divided by x squared times x to the power 1/2 times x to the power 1/2 times 1/2 dx. This is then equal to an integral of a 1 minus 1 divided by x squared times x to the power of 1/2 plus 1 divided by 4 dx, which is an integral from 1 minus 1 divided by x squared times x to the power of 3/4 dx. This is then equal to an integral of x to the power 3/4 dx minus an integral of 1 divided by x squared times x to the power of 3/4 dx. This is then equal to x to the power of 3/4 plus 1 divided by 3/4 plus 1 minus an integral of x to the power 3/4 minus 2 dx, which is equal to x to the power 7 divided by 4 divided by 7 divided by 4 minus x to the power of 3/4 minus 2 plus 1 divided by 3/4 minus 2 plus 1 plus a constant c. This is then equal to 4 divided by 7, the fourth root of x to the power 7, plus 4 times 1 divided by the fourth root of x, plus c. Integral number 20 on our list is an integral of x to the power 4 plus a square root of x cubed plus a square root of x plus 3 divided by x times a square root of x dx. Area in which this integral is defined is for all x's which are different than 0, because we have division by x, and x has to be larger or equal of 0 because of the square root. That means that x is larger than 0, and area in which this integral is defined is from 0 to positive infinity. This integral then becomes an integral of x to the power 4 divided by x square root of x dx plus an integral of square root x cubed divided by x square root of x dx plus an integral of square root of x divided by x square root of x dx plus 3 integrals of 1 divided by x square root of x dx, which is then equal to an integral of x to the power 4 minus 1 minus 1/2 dx plus an integral of x to the power 3/2 minus 1 minus 1/2 dx plus an integral of x to the power 1/2 minus x minus 1/2 dx plus 3 integrals of x to the power minus 1 minus 1/2 dx. This is then equal to an integral of x to the power 5 divided by 2 dx plus an integral of dx plus an integral of dx divided by x plus 3 integrals of x to the power negative 3/2 dx. This is then equal to x to the power of 5/2 plus 1 divided by 5/2 plus 1 plus x plus ln of absolute value of x plus 3x to the power minus 3/2 plus 1 divided by minus 3/2 plus 1 plus a constant c. This is then equal to x to the power 7/2 divided by 7/2 plus x plus ln of absolute value of x plus 3 times x to the power minus 1/2 divided by negative 1/2 plus c, which is equal to 2 divided by 7 x to the power 7/2 plus x plus ln of absolute value of x minus 6 times x to the power negative 1/2 plus c, which is equal to 2 divided by 7, a square root of x to the power 7 plus x plus ln of absolute value of x minus 6 times 1 divided by a square root of x plus a constant c. Problem number 21 is an integral of at plus b divided by t dt. Well, area in which this integral is defined is for all t's which are different than 0, and that makes d a set of real numbers without a 0. So this integral is equal to a times an integral of t dt plus b times an integral of dt divided by t, which is equal to a times t squared divided by 2 plus b times ln of absolute value of t plus c. The next integral on our list is an integral of e to the power t plus 1 divided by e to the power t dt. So this integral is defined in the entire set R, and it is equal to an integral of 1 plus e to the power negative t dt. This is equal to an integral of dt plus an integral of e to the power negative t dt, which is equal to t plus, and we can introduce a substitution at this point as u is equal to negative t, and then differential of u is equal to negative differential of dt, and then the integral becomes e to the power u, and dt is minus 1 times du. So this is equal to a t minus an integral of e to the power u du, which is t minus e to the power u plus a constant c. And when we return into the t world, this is t minus e to the power negative t plus c. The problem number 23 on our list is an integral of e to the power z, and in parentheses 1 minus e to the power negative z divided by z squared dz. Now this integral is defined for all z's which are different than 0, which means the area in which this integral is defined is the set R without a 0. This is then equal to integral of e to the power z dz minus an integral of dz divided by z squared. This is equal to e to the power z minus z to the power minus 2 plus 1 divided by minus 2 plus 1 plus c, which is then equal to e to the power z minus z to the power negative 1 divided by negative 1 plus c, which is equal to e to the power z plus 1 divided by z plus c. Integral number 24 on our list is an integral of a to the power u times 1 plus a to the power negative u divided by a square root of u cubed du. Now this integral is defined for all u's which are different than 0, and a has to be larger than 0. So this integral is then equal to an integral of a to the power u plus 1 divided by a square root of u cubed du. This is equal to an integral of a to the power u du and plus integral of u to the power negative 3/2 du. This is then equal to a to the power u divided by ln of a plus u to the power negative 3/2 plus 1 divided by negative 3/2 plus 1 plus a constant c. This is then equal to a to the power u divided by ln of a plus u to the power negative 1/2 divided by negative 1/2 plus c, which is ultimately equal to a to the power u divided by ln of a minus 2, 1 divided by a square root of u plus c. Now under the square root right here we have u cubed, and that also means that u cubed has to be always larger than 0, and that means that u has to be larger than 0. So area in which this integral is defined is for all a's which are from interval from 0 to positive infinity, and for all the u's which are for the interval from 0 to positive infinity. Now this integral is from the table, and this is its solution, but we are more used to it being written as e to the power x dx, and that is e to the power x plus c. This is only a special case of this integral. This integral can be proven that it is a to the power u du equal to a to the power u divided by ln of a. Of course, this is the same, and we just have division by ln of e, which is equal to 1. Integral number 25 on our list is an integral of 3 to the power y minus e to the power 3 plus y dy. Area in which this integral is defined is for all y's which are real numbers, and this integral is equal to an integral of 3 to the power y dy minus an integral of e to the power 3 plus y dy. This is then equal to 3 to the power y divided by ln of 3 minus e cubed times e to the power y plus c. Number 26 on our list is an integral of 2 to the power x plus 1 minus 5 to the power x minus 1 divided by 10 to the power x dx. And this integral, first, its area in which it is defined is for all x's which are real numbers. So this integral can be written as 2 to the power x plus 1 divided by 10 to the power x dx minus an integral of 5 to the power x minus 1 divided by 10 to the power x dx. And that is equal to 2 times an integral of 2 divided by 10 to the power x dx minus 1 divided by 5 integral of 5 divided by 10 to the power x dx. Now this is equal to 2 times integral of 1 divided by 5 to the power x dx minus 1/5 of integral of 5 divided by 10, that is 1/2 to the power x dx, and that is equal to 2 times 1 divided by 5 to the power x divided by ln of 1 divided by 5 minus 1/5 times 1/2 to the power x divided by ln of 1/2 plus a constant c. And this is then equal to 2 times 1 divided by 5 to the power x divided by ln of 5 to the power negative 1 minus 1/5 of 1 divided by 2 to the power x divided by ln 2 to the power negative 1 plus c, which is then equal to negative 2 divided by ln 5 times 1 divided by 5 to the power x plus 1 divided by 5 times ln of 2 times 1 divided by 2 to the power x plus c. Integral number 27 on our list is an integral of 2 divided by cubic root of x plus sine of x minus 3 divided by a square root of 1 minus x squared dx. Now, area in which this integral is defined, first x has to be different than 0 because we have this division right here, and 1 minus x squared has to be larger than 0. first larger or equal to 0 because it is under the square root, and then strictly larger because we would have division with a 0, which is not allowed. So x squared has to be smaller than 1, which makes 1 between negative 1 and 1. So that means that x has to belong in an interval from negative 1 to 1, and 0 has to be excluded from that interval. Then our integral becomes an integral of 2 divided by a cubic root of x dx plus an integral of sine x dx minus 3 integrals of dx divided by 1 minus x squared under the square root, which is then equal to 2 times an integral of x to the power negative 1/3 dx plus an integral of sine x dx, well, that is a negative cosine of x minus 3, and this integral right here is arcus sine of x plus a constant c. So this is then equal to 2 times x to the power negative 1/3 plus 1 divided by negative 1/3 plus 1 minus cosine of x minus 3 arcus sine of x plus c, which is finally equal to 2 times 3/2 times x to the power of 2/3 minus cosine of x minus 3 arcus sine of x plus c, which is equal to 3 times a cubic root of x squared minus a cosine of x minus 3 arcus sines of x plus c. Problem number 28 on our list is an integral of cosine 2x divided by sine squared of x times cosine squared of x dx. Now, area in which this integral is defined is for all sines of x which are different than 0, and cosine of x has also to be different than 0. Well, then x has to be different than kp, where k is an integer, and x has to be different from p half plus lp, where l is an integer. Well, that would make our area in which this integral is defined a set of all real numbers without the set of kp, where k are integers, and without the set p half plus lp, where l are integers. So then our integral becomes an integral of cosine 2x, well, that is cosine squared of x minus sine squared of x, a basic trigonometrical identity, and that is divided by cosine squared of x times sine squared of x dx. Well, that is then equal to a cosine squared of x divided by cosine squared of x sine squared of x dx minus an integral of sine squared of x divided by cosine squared of x sine squared of x dx, which is then equal to an integral of dx divided by sine squared of x minus an integral of dx divided by cosine squared of x. And that is equal to, just to remember, a tan of x derivative is equal to a sine of x divided by cosine of x derivative, which is equal to a cosine squared of x plus sine squared of x divided by cosine squared of x, which is equal to 1 divided by cosine squared of x. Well, that would mean that integral of 1 divided by cosine squared of x dx is equal to tan of x plus an arbitrary constant c. Now, for a function cot of x, derivative is cosine of x divided by sine of x, and then the derivative of that, which would make a negative sine squared of x minus cosine squared of x divided by sine squared of x, which is equal to negative 1 divided by sine squared of x. And then an integral of 1 divided by sine squared of x is equal to a negative cot of x plus c. So when we return this into our problem, it becomes minus cot of x minus tan of x plus an arbitrary constant c. Problem number 29 on our list is an integral of dx divided by sine squared of x cosine squared of x. Now, area in which this integral is defined is for all sine x which have to be different than 0, and cosine of x has also to be different from 0. That means that x has to be different from kp, where k is an integer, and x has to be different than p half plus lp, where l is an integer. Well, that means that area in which this integral is defined is set of all real numbers when we exclude from it dots of the kp, where k is an integer, and all the dots p half plus lp, where l is an integer. So then our integral becomes an integral of 1 divided by sine squared of x plus 1 divided by cosine squared of x dx. Of course, I would have to give a little explanation for this. We have in this point the term 1 divided by sine squared of x times cosine squared of x. 1 can be written as cosine squared of x plus sine squared of x, of course divided by cosine squared of x times sine squared of x, and that is equal to cosine squared of x divided by cosine squared of x times sine squared of x plus sine squared of x divided by cosine squared of x times sine squared of x. Cosine and cosine can cancel out, and we have 1 divided by sine squared of x plus sine and sine cancel out, and we have 1 divided by cosine squared of x. Now this integral is equal to an integral of 1 divided by sine squared of x dx plus an integral of 1 divided by cosine squared of x dx. And that is equal to negative cot of x plus tan of x plus an arbitrary constant c. Now problem 30 on our list is an integral of ctg squared of x dx. Now a little note, it depends on the literature which you use, but ctg of x is defined as cosine of x divided by sine of x, and of course that is a cot function of x. So depending on the literature which you use, you might find one or the other notation for one and the same thing. So this is equal to an integral of cot squared of x dx. So then this is equal to, we have cot, and that is cosine of x divided by sine of x squared dx, which is then equal to an integral of 1 minus sine squared of x divided by sine squared of x dx, and that is equal to an integral of 1 divided by sine squared of x dx minus an integral of dx, and that is equal to negative cot of x minus x plus c. And the area in which this integral is defined, as we have cot function is defined when sine of x has to be different than 0. So x is different than kp, and k are integers. So we are talking about the set R without the dots kp, where k is an integer. The next integral is 31 on our list, tg squared of x dx. Now, function tg of x is defined as sine of x divided by cosine of x, which is a function tan of x. So depending on the literature you use, you might find one notation or the other. They mean the same thing. So this is equal to an integral of tan squared of x dx, which is equal to a sine of x divided by cosine of x squared dx. And in order for this integral to be well defined, cosine of x has to be different than 0. That means that x has to be different from p half plus kp, where k is an integer. That makes the area in which this integral is defined to be set R without the dots p half plus kp, where k is an integer. This integral then becomes an integral of 1 minus cosine squared of x divided by cosine squared of x dx, which is equal to an integral of 1 divided by cosine squared of x dx minus an integral of dx. This is then equal to tan of x minus x plus c. Integral number 32 on our list is an integral of 3 minus 2 ctg squared of x divided by cosine squared of x dx. Now, area in which this integral is defined is for all cosines of x is different than 0, and because we have a cot function right here, the sine of x has also to be different from 0. Well, that means that x has to be different from p half plus kp, where k is an integer, and x has to be different from lp, where l is an integer. So that means that area in which this integral is defined is a set of all real numbers without the subset of all the dots of p2 plus kp, where k is an integer, union all the dots represented by lp, where l is an integer. This integral then becomes, so our integral is then equal to an integral of 3 divided by cosine squared of x dx minus 2 integrals of cot squared of x divided by cosine squared of x dx. This is then equal to 3 times an integral of dx divided by cosine squared of x minus 2 integrals of cosine squared of x dx divided by sine squared of x times cosine squared of x. This is then equal to 3 tan of x minus 2, and these cosines squared can cancel each other out, so we get minus cot of x plus c. So the final solution is 3 tan of x plus 2 cot of x plus c. Integral 33 on our list is an integral of sine squared of x half dx. Area in which this integral is defined is for all x's which are real numbers. What we can do in a situation like this is to use trigonometrical identities. Cosine squared of x half plus sine squared of x half is equal to 1, and cosine squared of x half minus sine squared of x half is equal to cosine 2 times x half, which is just cosine of x. If we subtract these two equations from one another, we get that 2 sine squared of x half is equal to 1 minus cosine of x, which means that sine squared of x half is equal to 1 half of 1 minus cosine of x. If we return this result in our integral, we get that it is equal to an integral of 1 half 1 minus cosine of x dx, which is equal to 1 half integral dx minus 1 half integral of cosine x dx. And this is just 1 half of x minus 1 half of sin x plus a constant c. Integral number 34 on our list is an integral of sine x half minus cosine of x half, that entire thing squared, dx. Now, area in which this integral is defined is for all x's which are real numbers, and this integral is equal to an integral of sine squared of x half minus 2 times sine of x half cosine of x half plus cosine squared of x half dx. And this is equal to an integral. Well, these two paired are just going to give us 1 minus 2 sine of x half cosine of x half dx. That is equal to an integral of 1 minus, well, 2 times sine of a half angle times cosine of a half angle is sine of a double angle. So this is minus sine of x dx. So this is then equal to an integral of dx minus an integral of sine x dx, and this is just x plus cosine x plus c. Integral number 35 on our list is an integral of cosine squared of x half dx. Now, the area for this integral is for all x's which are real numbers, area where this integral is defined, and what we can use is the trick from a previous problem where we write cosine squared x half plus sine squared x half is 1, and cosine squared of x half minus sine squared of x half is a cosine of x. When we add these two equations to one another, we get that 2 cosine squared of x half is equal to 1 plus cosine of x, and that gives us that cosine squared of x half is 1 half of 1 plus cosine of x. So our integral then becomes 1 half of an integral of 1 plus cosine x dx, which is 1 half of the integral dx plus 1 half of the integral cosine x dx, which is 1 half of x plus a sine x plus c, 1 half. Problem number 36 on our list is an integral of e to the power negative z, 1 plus e to the power z divided by cosine squared of z dz. Well, in order for this to be well defined, cosine of z has to be different than 0, and that means that z has to be different than p half plus kp, where k is an integer. So that is going to give us an area in which this integral is defined as a set R without the dots p half plus kp, where k is an integer. Now our integral becomes an integral of e to the power negative z dz plus an integral of e to the power z dz divided by cosine squared of z. What we can do now is to introduce a substitution that t is equal to negative z, and then dt becomes negative dz, and that transforms our integral into minus an integral of e to the power t dt plus, oh, okay, this is a mistake, I don't have this here. E to the power negative z times e to the power z is e to the power negative z plus z, which is 0, and that is 1. So I have here just an integral of dz divided by cosine squared of z, and in the table that is just a tan of z and plus c. So I actually have negative e to the power t plus tan of z plus c, and that is minus e to the power negative z plus tan of z plus c. Integral number 37 on our list is an integral of 4 dt divided by a square root of 4 minus 4t squared. So this integral is equal to an integral of 4 dt divided by 2 times an integral of 1 minus t squared. And that is equal to 2 integrals of dt divided by a square root of 1 minus t squared, and that is equal to 2 times arcus sine of t plus c. Now, for this integral to be well defined, 1 minus t squared has to be larger or equal to 0, and 1 minus t squared has to be different than 0. So that means that 1 has to be larger or equal to t squared, and that gives us t to be inside the interval from a minus 1 to 1, where borders are included in the interval, and this means that t has to be different from plus or minus 1, so finally t is from an open interval minus 1 to 1. Integral number 38 on our list is an integral of a to the power u in bracket 1 plus a to the power negative u divided by 1 plus u squared du. So this is equal to an integral of a to the power u du plus an integral of a to the power u a times a to the power negative u, that is a to the power 0, which is 1, that is just du, and in the denominator we have a 1 plus u squared. So that is going to be equal, integral of a to the power u is a to the power u divided by ln of the base, which is a in this case, and plus this is an arcus tan function of u and plus a constant c. And of course this integral is defined for all the u's, which are real numbers, and a has to be larger than 0. Integral number 39 on our list is an integral of 1 minus sine cubed of x divided by a sine squared of x dx. For this integral to be well defined, sine of x has to be different from 0, and that means that x is different from kp, and k has to be an integer. So the area in which this integral is defined is the set of real numbers excluded dots kp, where k is an integer. This integral is then equal to an integral 1 divided by sine squared of x dx minus an integral sine cubed of x divided by sine squared of x dx, which is equal to a negative cot of x minus an integral of sine x dx, that is negative cot of x plus a cosine of x plus a constant c. Now the integral number 40 on our list is an integral of a divided by x minus b divided by a square root of 1 minus x squared dx. Okay, for this integral to be well defined, x has to be different from 0, and 1 minus x squared has to be strictly larger than 0. That means that 1 has to be larger than x squared, and that puts x in the interval from a minus 1 to 1, where borders are not included in the interval. So that means that the area in which this integral is defined is for all x's which are inside the interval from -1 to 0, union from 0 to 1. And of course, these numbers a and b are real numbers. So this integral is then equal to an integral of a times dx divided by x minus b, an integral dx divided by a square root of 1 minus x squared, and that is equal to a times ln of absolute value of x minus b times arcus sine of x and plus an arbitrary constant c. Integral number 41 on our list is an integral of a dx divided by b plus bx squared. In order for this integral to be well defined, a first is a real number, and b has to be different from 0 because division with 0 is not allowed, and x can be any real number. This integral is equal to a divided by b integral of dx divided by 1 plus x squared, and this is a over b tan of x plus c. Integral number 42 on our list is an integral of 4 cosine z minus 5 divided by a square root of 9 minus 9z squared dz. So this is equal to 4 times an integral of cosine z dz minus 5 divided by 3 integral of dz divided by a square root of 1 minus z squared. This is then equal to 4 times sine of z minus 5/3 of arcus sine of z plus c. And the area in which this integral is defined is for all z's which are from a minus 1 to 1 open interval. Now the integral number 43 on our list is an integral of x to the power 4 divided by 1 plus x squared dx. Now x to the power 4 divided by x squared plus 1 is equal to x squared. X to the 4th power divided by x squared is x squared. X squared times x squared is x to the power 4, and then plus x squared times 1 is x squared. And when we subtract this, we get x to the power 4 minus x to the power 4, that is 0, so we are left with minus x squared. Minus x squared divided by x squared is negative 1. Negative 1 times x squared is negative x squared. Negative 1 times positive 1 is negative 1. And when we subtract these, we get just 1. So x to the 4th power divided by x squared plus 1 is equal to x squared minus 1 plus 1 divided by x squared plus 1. And when we return this into an integral which we started from, we get that this integral is equal to an integral of x squared minus 1 plus 1 divided by x squared plus 1 dx. This is an integral of x squared dx minus an integral of dx plus an integral of dx divided by 1 plus x squared. This is then equal to x cubed divided by 3 minus x plus arcus tan of x plus c. Now the integral number 44 on our list is an integral of 2 divided by 1 plus x squared minus 3 divided by a square root of 1 minus x squared plus 4 divided by x dx. Okay, this is equal to 2 times an integral of dx divided by 1 plus x squared minus 3 integrals of dx divided by a square root of 1 minus x squared plus 4 times an integral of dx over x. And this is equal to 2 times arcus tan of x minus 3 arcus sine of x plus 4 times ln of absolute value of x and plus an arbitrary constant c. Now, the area in which this integral is defined is for all x's that are from -1 to 1 without the dot 0. The integral number 45 on our list is an integral of x squared plus x times a cubic root of x plus a squared root of x divided by x times a square root of x dx. Now this integral is defined when x is different from 0 and x has to be larger or equal to 0. So the area in which this integral is defined is for 0 to positive infinity and an open interval for that matter. So this integral then becomes x squared divided by x times a square root of x dx plus an integral of x times a cubic root of x divided by x square root of x dx plus an integral of square root of x divided by x times square root of x dx. This is then equal to an integral of x 2 minus 1 minus 1 half dx plus an integral x and x are going to cancel out. So this is x to the power 1/3 minus 1 half dx plus an integral square root of x is going to cancel out and we're left with dx divided by x. So this is then equal to an integral of x to the power 1/2 dx plus an integral of x to the power 1 divided by 6 dx, and that is negative 1 divided by 6, and plus ln of absolute value of x and plus an arbitrary constant c. So this is equal to x 1/2 plus 1 divided by 3/2 plus x to the power negative 1/6 plus 1 divided by 5/6 plus ln of absolute value of x plus c, and this is equal to 2/3 a square root of x cubed plus 6 divided by 5 sixth root of x to the 5th power plus ln of absolute value of x plus c. Now x is only a positive number, so we don't need absolute value here. So this is 2/3 x cubed under the square root 6/5 x to the 5th power and 6th root plus ln of x plus c as a final solution to this integral. Problem number 46 on our list is an integral of x minus a cubic root of x squared minus x to the power negative 1/2 divided by x times a square root of x dx. Now, area in which this integral is defined is for all number x's which are larger than 0. This integral is equal to an integral of x divided by x square root of x dx minus an integral of x to the power 2/3 divided by x square root of x dx minus an integral of x to the power negative 1/2 divided by x square root of x dx. And that is equal to integral x and x can cancel out, and we are left with an x at the power of negative 1/2 dx minus an integral of x to the power 2/3 minus 1 minus 1/2 dx minus an integral of x to the power negative 1/2 minus 1 minus 1/2 dx. This is then equal to x to the power negative 1/2 plus 1 divided by negative 1/2 plus 1 minus an integral of x to the power 4 minus 6 minus 3 divided by 6 dx minus an integral of x to the power negative 2 dx. This is then equal to 2 square roots of x minus x to the power negative 5 divided by 6 plus 1 divided by negative 5 over 6 plus 1 minus x to the power negative 2 plus 1 divided by minus 2 plus 1 and plus an arbitrary constant c. This is then equal to 2 square roots of x minus 6/6 integral of x plus 1 divided by x plus c. Now, integral number 47 on our list is an integral of e to the power 2x plus e to the power x times a sine of x divided by e to the power x dx. This integral is defined for all x's which are real numbers, and this integral can be written as e to the power 2x divided by e to the power x dx plus an integral of e to the power x sine of x divided by e to the power x dx. This is then equal to an integral of e to the power 2x minus x dx plus an integral of e to the power x can cancel out, and we are left with sine of x dx, which is equal to integral of e to the power x dx plus an integral of sine x dx, which is equal to e to the power x minus cosine of x plus an arbitrary constant c. Integral number 48 on our list is an integral of 2 cosine squared of y plus 1 divided by cosine squared of y dy. This integral is defined when cosine y is different from 0, and that means that y has to be different from p half plus kp, where k is an integer. This integral can be then written as an integral of 2 cosine squared of y divided by cosine squared of y dy plus an integral of 1 divided by cosine squared of y dy. This is then equal to 2 integrals of dy because cosine squared of y can cancel out, and plus an integral of dy divided by cosine squared of y. This is equal to 2y plus tan of y plus an arbitrary constant c. Problem 49 on our list is an integral of ax to the power 3 plus bx squared plus cx plus d differential of x. Well, this integral is defined for a, b, c, and d, which are real numbers, they are constants, and x can be a real number as well. So this integral then becomes an a times an integral of x cubed dx plus b times an integral of x squared dx plus c times an integral of x dx and plus d times an integral of dx. This is then equal to a times x to the power 4 divided by 4 plus b times x cubed divided by 3 plus c times x squared divided by 2 plus dx d, and this integral is equal to x, and plus an arbitrary constant c. Just a little note, this c is different from this c. This is an input of our problem, and this c is just a constant which is a real number. Integral number 50 on our list is an integral of x cubed minus x squared plus 1 divided by x squared minus 1 divided by x cubed dx. This integral is defined for all x's which are real numbers except the number 0. And then this integral is equal to an integral of x cubed dx minus integral of x squared dx plus an integral of x to the power negative 2 dx and minus an integral of x to the power negative 3 dx. This is then equal to x to the power 4 divided by 4 minus x cubed divided by 3 minus 1 divided by x and plus 1/2 times 1 divided by x squared and plus an arbitrary constant c. Integral number 51 on our list is an integral of x squared plus a square root of x cubed plus 3 divided by a square root of x dx. Now this integral is defined for all x's which are larger than 0, and it can be written as x squared divided by a square root of x dx plus an integral of square root of x cubed divided by a square root of x dx plus an integral of 3 divided by a square root of x dx. This is then equal to an integral of x to the power 2 minus 1/2 dx plus an integral of x to the power 3/2 minus 1/2 dx plus 3 integrals of x to the power negative 1/2 dx. And then this is equal to x to the power 3/2 plus 1 divided by 3/2 plus 1 plus x squared divided by 2 plus 3 times x to the power negative 1/2 plus 1 divided by negative 1/2 plus 1 and plus an arbitrary constant c. This is then equal to x to the power 5/2 divided by 5/2 plus x squared divided by 2 and plus 3x to the power 1/2 divided by 1/2 plus c. This is equal to 2 divided by 5 square root of x to the 5th power plus x squared divided by 2 plus 6 square roots of x plus c. Problem number 52 on our list is an integral of 4 minus x divided by 2 plus a square root of x dx. Now, area in which this integral is defined is for all x's which are larger or equal to 0, and this integral can be written as an integral of 2 minus a square root of x times 2 plus a square root of x divided by 2 plus a square root of x dx. These two are then going to cancel out, and we are left with two integrals of dx minus an integral of square root of x dx, which is equal to 2x minus x to the power 1/2 plus 1 divided by 1/2 plus 1 and plus an arbitrary constant c. This is equal to 2x minus 2/3 of a square root of x cubed and plus c. Integral number 53 on our list is an integral of 18x squared minus 2 divided by 3x minus 1 dx. This is then equal to, well, this integral is defined for 3x minus 1 different than 0, and that means that x has to be different from 1/3. So an area in which this integral is defined is a set of all real numbers without 1/3. And this integral can be written as an integral of 2 times 9x squared minus 1 divided by 3x minus 1 dx, which makes it equal to 2 integrals of 3x minus 1 times 3x plus 1 divided by 3x minus 1 dx. Now 3x minus 1 can cancel out, and we are left with 2 integrals of 3x plus 1 dx, which is equal to 6 integrals of x dx and plus 2 integrals of dx. That is equal to 6 times x squared divided by 2 plus 2x plus an arbitrary constant c. So this is 3x squared plus 2x plus c. Integral number 54 on our list is an integral of a 1 plus x squared divided by x 1 plus x squared dx. So the area in which this integral is defined is for all x's which are different than 0. This integral can be written as an integral of 1 plus 2x plus x squared divided by x times 1 plus x squared dx. And then this can be written as an integral of 1 divided by x times 1 plus x squared dx plus 2 times an integral of x divided by x 1 plus x squared dx and plus an integral of x squared divided by x 1 plus x squared dx. Well, let's observe this first integral. 1 over x times 1 plus x squared can be factored out as a divided by x plus bx plus c divided by 1 plus x squared. This is a polynomial of the second degree, and that is why we have a linear function right here. So this is equal to a times 1 plus x squared plus bx plus c times x divided by x times 1 plus x squared. That means that 1 is equal to a plus a times x squared plus bx squared plus cx. And that means that a is equal to 1, and a plus b has to be equal to 0, and c is equal to 0. First and second equation are going to give us that b is equal to negative 1. So this expression 1 divided by x 1 plus x squared can be written as 1 divided by x minus x divided by 1 plus x squared. When x and x cancel out in this integral, it just becomes an integral of dx divided by 1 plus x squared, and that is arcus-tan of x. And when x and x cancel out in this integral, we are left with x divided by 1 plus x squared dx. That is the same integral which we have from this point right here. So this expression then becomes integral of dx divided by x minus an integral of x dx divided by 1 plus x squared plus 2 times arcus-tan of x plus an integral of x divided by 1 plus x squared dx. Second and fourth integral are going to cancel out each other, and this is equal to ln of absolute value of x plus 2 times arcus-tan of x plus c. Integral number 55 on our list is an integral of a to the power 2 divided by 3 minus x to the power 2 divided by 3 and all of that cubed dx. Area in which this integral is defined is for all real numbers a and all real numbers x. This integral is then equal to an integral of a to the power 2 divided by 3 cubed minus 3 times a to the power 2 divided by 3 squared times x to the power 2 divided by 3 plus 3 times a to the power 2 thirds times x to the power 2 thirds squared minus x to the power 2/3 cubed dx. And then this is equal to a squared x minus 3a to the power 4 divided by 3 integral of x to the power 2 divided by 3 dx plus 3 times a to the power 2/3 times x to the power 4/3 plus 1 divided by 4/3 plus 1 minus x cubed divided by 3 plus c. This is then equal to a squared x minus 3a to the power 4 divided by 3 times 3 divided by 5 x to the power 5 divided by 3 plus 3a to the power 2 divided by 3 times 3 divided by 7 x to the power 7 divided by 3 minus x cubed divided by 3 plus c, which is then equal to a squared x minus 9 divided by 5 cubic root of a to the power 4 times cubic root of x to the power 5 plus 9 divided by 7 cubic root of a squared times cubic root of x to the power 7 minus 1/3 of x cubed plus c. Integral number 56 on our list is an integral of x to the power m minus x to the power n squared divided by a square root of x dx. Area in which this integral is defined is for all x's which are strictly larger than 0. This is then equal to an integral of x to the power 2m minus 2 times x to the power m times x to the power n plus x to the power 2n divided by a square root of x dx. This is then equal to an integral of x to the power 2m minus 1/2 dx minus 2 integrals of x to the power m plus n minus 1/2 dx plus an integral of x to the power 2n minus 1/2 dx. This is then equal to x to the power 2m minus 1/2 plus 1 divided by 2m minus 1/2 plus 1 minus 2 times x to the power m plus n minus 1/2 plus 1 divided by m plus n minus 1/2 plus 1 and plus x to the power 2n minus 1/2 plus 1 divided by 2n minus 1/2 plus 1 and plus constant c. This is then equal to x to the power 2m plus 1/2 divided by 2m plus 1/2 minus 2x's to the power m plus n minus 1 plus 1/2 divided by m plus n plus 1/2 plus x to the power 2n plus 1/2 divided by 2n plus 1/2 plus c. Integral number 57 on our list is an integral of square root of x plus 1 times an integral of x minus square root of x plus 1 dx. Now, area in which this integral is defined is for all x's which are larger or equal to 0, and this integral can be written as an integral of x times the square root of x plus x minus a square root of x plus a square root of x plus 1 dx. This is then equal to x and minus x can cancel out, and the negative square root of x and positive square root of x can cancel out. So this becomes integral of x to the power 3 divided by 2 dx plus an integral of dx, which is equal to x to the power 3 halves plus 1 divided by 3 halves plus 1 plus x plus c, which is equal to 2 over 5 x to the 5th power under the square root plus x plus c. Integral number 58 on our list is an integral of x squared plus 1 times x squared minus 2 divided by cubic root of x squared dx. Area in which this integral is defined is for all x is different than 0, and this integral can be written as an integral of x to the 4th power minus 2x squared plus x squared minus 2 dx divided by cubic root of x squared. So this integral is then equal to an integral of x to the 4th power minus x squared minus 2 divided by a cubic root of x squared dx. This is then equal to an integral of x to the power 4 minus 2/3 minus x to the power 2 minus 2/3 and minus 2x to the power negative 2/3 dx. This is then equal to integral of x to the power 10 over 3 minus x to the power 4 over 3 minus 2x to the power negative 2 over 3 dx, which is equal to x to the power 10 over 3 plus 1 divided by 10 over 3 plus 1 minus x to the power 4 over 3 plus 1 divided by 4 over 3 plus 1 and minus 2x to the power 1/3 divided by 1/3 and plus a constant c. So this is equal to 3 over 13 cubic root of x to the power 13 minus 3 over 7 cubic root of x to the 7th power minus 6 cubic roots of x and plus a constant c. Now integral number 59 on our list is an integral of 5 minus 2x to the power 9 dx. We are going to introduce the substitution as t is equal 5 minus 2x and then differential of t is equal to negative 2 differentials of dx, which makes 1/2 of the differential of t equal to a differential of x. When we returned this into an integral which we started from, it becomes negative 1/2 of an integral t to the power 9 dt, which is equal to negative 1/2 times t to the power 10 divided by 10 plus c, and this is equal to negative 1 over 20 5 minus 2x to the 10th power plus c. Integral number 60 on our list is an integral of 4x plus 3 on the power 1/3 dx. Area in which this integral is defined is for all x's which are real numbers, and this is then equal to, we can introduce the substitution as t is equal to 4x plus 3, which makes differential of t to be equal to 4 differentials of x. Now this integral becomes 1 divided by 4 integral of t to the power 1/3 dt, which is equal to 1 over 4 times t to the power 1/3 plus 1 divided by 1/3 plus 1 and plus a constant c. So this is equal to 1 divided by 4 times t to the power 4 divided by 3 over 4 divided by 3 plus c. Well, that is equal to 1 divided by 4 times 3 divided by 4 times a cubic root of t to the 4th power plus c, which is equal to 3 divided by 16 cubic root of 4x plus 3 to the 4th power and plus c. Integral number 61 on our list is an integral of dy divided by 3y plus 2. The area in which this integral is defined is for 3y plus 2 to be different than 0. That means that y has to be different than a negative 2/3. If we introduce the substitution t as 3y plus 2, we get that differential of t is equal to 3 differentials of y. Then our integral, when transformed into the t world, becomes dt divided by t and times 1/3. This is equal to 1/3 of ln of the absolute value of t plus an arbitrary constant c, and when we return into the x world, we get 1/3 of the ln of 3y plus 2 and plus c. Integral number 62 on our list is an integral of x dx divided by 1 plus x squared. Now, this integral is defined for all x's which are real numbers, and we can solve this integral by introducing the substitution that t is equal to 1 plus x squared, and then differential of t is equal to 2x dx. Our integral then gets transformed into the t world as 1/2 of the integral dt over t, and that is equal to 1/2 of the ln of the absolute value of t plus c, which is equal to 1/2 of the ln of the absolute value of 1 plus x squared plus c. As 1 plus x squared is always larger than 0, we can omit the absolute value in this case. Integral number 63 on our list is an integral of x dx divided by a square root of 1 minus x squared. Now, area in which this integral is defined is for all 1's minus x squares larger than 0. That means that 1 has to be larger than x squared, and that means that x has to be from the interval -1 to 1. It's an open interval. So this integral then gets transformed by introducing the substitution that t is equal to a square root of 1 minus x squared, and then we get that differential of t is equal to 1 over 2 square roots of 1 minus x squared times a negative 2x differential of x, which is equal to negative x dx divided by a square root of 1 minus x squared. This is then equal to negative dt, and that is equal to negative t plus c. And when we return into the x world, we get negative square root of 1 minus x squared plus c. Problem number 64 on our list is an integral of x dx divided by x squared plus 1 and then the entirety squared. Area in which this integral is defined is for all x's which are real numbers, and we can solve this integral by introducing the substitution that t is equal to x squared plus 1. Differential of t is then equal to 2x dx, which means that x dx is equal to 1/2 of the differential of t. Our beginning integral becomes an integral of dt 1/2 divided by t squared. This is then equal to 1/2 of the integral of t to the power -2 dt, which is equal to 1/2 times t to the power of -2 plus 1 divided by -2 plus 1 plus an arbitrary constant c. This is then equal to 1/2 times 1 divided by minus t plus c, which is equal to negative 1/2 times 1 divided by 1 plus x squared plus c. Integral number 65 on our list is an integral of dx divided by a cubic root of 3 minus 2x to the 4th power. Now, area in which this integral is defined is for all 3 minus 2x is different than 0, and that means that x has to be different from 3/2. So area in which this integral is defined is a set of all real numbers with 3/2 excluded from it. We can solve this integral by introducing the substitution that t is equal to 3 minus 2x, and then dt becomes negative 2 dx. This integral then transforms into negative 1/2 of the integral dt of 3 squared root of a cubic root of t to the 4th power, which is equal to negative 1/2 of t to the power negative 4 over 3 differential of t. This is then equal to negative 1/2 times t to the power negative 4 over 3 plus 1 divided by negative 4 over 3 plus 1 and plus an arbitrary constant c. This is then equal to negative 1/2 times t to the power negative 1/3 divided by negative 1/3 plus c. This is then equal to 3/2 times 1 divided by a cubic root of t plus c. And when we return this into the x world, we get 3/2 times 1 divided by a cubic root. T was 3 minus 2x, and of course plus c. Integral number 66 on our list is an integral of x squared dx divided by x cubed plus 1. Area in which this integral is defined is for x cubed plus 1 to be different than 0, and that means that x cubed has to be different than a negative 1. That means that x has to be different from negative 1. We can introduce the substitution that t is equal to x cubed plus 1, and then differential of t is equal to 3x squared dx. Then x squared dx becomes equal to 1/3 of the differential of t. And when we return this into our integral, we get 1/3 integral of dt divided by t, which is 1/3 of ln absolute value of t plus an arbitrary constant c. This is then equal to 1/3 of the ln of the absolute value x cubed plus 1 plus c. Integral number 67 on our list is an integral of 2x plus 1 divided by x squared plus x minus 3 dx. This integral is defined for x squared plus x minus 3 different than 0, and x squared plus x minus 3 is equal to 0 in the dots a and b, which are real numbers. That means that a and b are a root of this second degree polynomial, and we can write that as x squared plus x minus 3 equal to x minus a times x minus b, which then becomes x squared minus bx minus ax plus ab. That is equal to x squared minus a plus b in parenthesis x and plus ab. That means that negative a plus b in parentheses is equal to 1, and a times b is equal to negative 3. Well, a plus b is then equal to negative 1, and a times b is equal to negative 3. Well, that means that there exist negative 1/2 plus u and negative 1/2 minus u, such that negative 1/2 plus u times negative 1/2 minus u is equal to negative 3. Negative 1/2 plus u times negative 1/2 minus u is equal to negative 1/2 squared minus u squared, which is equal to 1/4 minus u squared. That means that 1/4 minus u squared is equal to negative 3, and that means that u squared has to be equal to 1/4 plus 3, which is equal to 1 plus 12, and that is 13/4. So u is then equal to a square root of 13 divided by 2. And that means that minus 1/2 plus u is equal to negative 1/2 plus a square root of 13 divided by 2. And negative 1/2 minus u is equal to negative 1/2 minus a square root of 13 over 2. Well, that means that a is equal to negative 1/2 plus a square root of 13 over 2, and that b is equal to negative 1/2 minus a square root of 13 over 2, and thus we have found the solution. So this integral is defined for all real numbers r, excluding a and b, that is minus 1/2 plus a square root of 13 over 2 and minus 1/2 minus a square root of 13 over 2. Now, to solve this integral from the beginning, we can do that by introducing the substitution that t is equal to x squared plus x minus 3, and then differential of t is equal to 2x plus 1 dx. So this integral is transformed into the t world as dt divided by t, which is ln of absolute value of t plus an arbitrary real constant c. Then this is equal to ln of the absolute value of x squared plus x plus minus 3 plus c. Problem number 68 on our list is an integral of the square root of a squared plus b squared x squared times x dx. Now, area in which this integral is defined for all parameters a and b, which are real numbers, and a variable x, which is a real number. So this then can be solved using a substitution that t is equal to a squared plus b squared x squared, and then differential of t is equal to b squared times 2x dx. Well, then integral is transformed into the t world, and it looks like an integral of a square root of t times x dx, which is this part. So that gives us dt divided by 2b squared. This is then equal to 1 divided by 2b squared integral of t to the power 1/2 dt, which is equal to 1 divided by 2b squared, and t to the power 1/2 plus 1 divided by 3/2 and plus an arbitrary constant c. So this is equal to 1 divided by 2b squared times 2 divided by 3 times a square root of t to the power 3 and plus c, which is equal to 1 divided by 3b squared times a square root of a squared plus b squared x squared to the third power and plus a constant c. Integral number 69 on our list is an integral of 1 plus x divided by a square root of 1 minus x squared dx. Area in which this integral is defined is for all 1 minus x squared larger than 0, and that means that x squared has to be smaller than 1, which makes x belong in an open interval from -1 to 1. Now this integral is then equal to an integral of dx divided by a square root of 1 minus x squared plus an integral of x dx divided by a square root of 1 minus x squared. This is then equal to, this is a table integral equal to arcus sine of x. And we can solve this other integral by introducing the substitution that t is equal to a square root of 1 minus x squared. Differential of t is then equal to 1 divided by 2 square roots of 1 minus x squared times negative 2x differential of x. Differential of t is then equal to negative x divided by a square root of 1 minus x squared dx. When we return into our problem, this then becomes minus an integral of dt and plus an arbitrary constant c, which is arcus sine of x minus t plus c, which is equal to arcus sine of x minus a square root of 1 minus x squared plus c. Integral number 17 on our list is an integral of a square root of 1 minus x divided by 1 plus x dx. Now, area in which this integral is defined is for x different than a negative 1 and 1 minus x divided by 1 plus x strictly larger than 0. Well, that means that 1 minus x has to be larger than 0 and 1 plus x has to be larger than 0, or 1 minus x has to be smaller than 0 and 1 plus x has to be smaller than 0. So this means that x is smaller from 1 and x is larger than a negative 1, or 1 is smaller than x and x is smaller than a negative 1. Well, if we track 1 minus x and 1 plus x, we see that in the dots negative 1 and 1, the sign changes as follows. This is positive, positive, and then negative. And this is negative, positive, and positive here. So the combination of both of these signs is going to give us negative, positive, and negative. Since we need this to be positive, this is the interval in which we are. So x then belongs in an open interval from negative 1 to 1. And this part right here means that negative 1 and 1 are here. Negative 1x has to be in this position right here. And since 1 is smaller than x has to be in this position right here, which gives us nothing. Union of these two intervals is just an interval from negative 1 to 1. Now the integral which we started from can be transformed. It is an integral of 1 minus x divided by a square root of 1 plus x dx. What we can do now is we can multiply this integral by a conveniently written number 1. So we get a square root of 1 minus x divided by a square root of 1 plus x times a square root of 1 minus x divided by a square root of 1 minus x dx. This is then equal to an integral of 1 minus x divided by a square root of 1 minus x squared dx. This is then equal to an integral of dx divided by a square root of 1 minus x squared minus an integral of x dx divided by a square root of 1 minus x squared. This is then equal to arcus sine of x plus a square root of 1 minus x squared plus c. Problem number 71 on our list is an integral of dx divided by x squared plus a squared. This integral is defined for a different than 0, and then x can be any real number. So let's solve this integral in this area. So that means that integral can be written as 1 divided by a squared integral of dx divided by x over a squared plus 1, and that is equal to, by introducing the substitution that t is equal to x over a, we get a differential of t as 1 over a dx. This is then equal to 1 divided by a square, an integral of differential of t divided by 1 plus t squared. This is then equal to 1 divided by a arcus tan of t and plus c, which is equal to 1 over a arcus tan of x divided by a plus c. And in our second case, if a is equal to 0, well, that means that x has to be a real number different from 0. So in this case, the integral becomes an integral of dx divided by x squared, which is equal to x to the power of negative 2 dx integral. So this is x to the power of negative 2 plus 1 divided by 1, negative 1 plus c, which is equal to negative 1 over x plus c. Integral number 72 on our list is an integral of dx over x squared plus 3. Of course, the area in which this integral is defined is for all x's which are real numbers. So this is then equal to dx divided by x squared plus a squared root of 3, and that squared, which is equal, according to the first case in the previous problem, to 1 divided by a square root of 3 arcus tan of x divided by a square root of 3 and plus c. Problem number 73 on our list is an integral of dx divided by 2 plus 3x squared. Area in which this integral is defined is set of all real numbers, and this integral can be written as an integral of dx divided by 2 in brackets 1 plus 3x squared divided by 2. This is then equal to 1/2 of the integral dx over 1 plus a square root of 3 divided by a square root of 2x, and that is squared. We can now introduce a substitution that a square root of 3 divided by a square root of 2 times x is equal to t, and that means that a square root of 3 divided by a square root of 2 dx is equal to a differential of t. Well, that makes the differential of x being equal to square root of 2 divided by a square root of 3 dt. So this integral is then transformed into the t world as 1/2 of the integral of 1 divided by 1 plus t squared times the square root of 2 divided by a square root of 3 dt, which is 1 divided by a square root of 6 integral of dt divided by 1 plus t squared, which is then equal to 1 divided by a square root of 6 arcus tan of t plus an arbitrary constant c, which is equal to 1 divided by a square root of 6 arcus tan of t, which was a square root of 3 divided by a square root of 2x plus c. We can then rationalize this, and it becomes 1 divided by a square root of 6 times arcus tan of a square root of 6 divided by 2 times x plus c. Number 74 on our list is an integral. Number 74 on our list is an integral of dx divided by 25 plus 4x squared. Now, the area in which this integral is defined is all real numbers. So this integral is then equal to dx divided by, if we take 25 outside of the bracket, we get 1 plus 4 divided by 25x squared, and that is equal to 1 divided by 25 integral of dx divided by 1 plus 2x divided by 5 squared. T is equal to 2x divided by 5, and then differential of t is 2 divided by 5 dx, which makes 5 halves of dt be equal to dx. This integral then becomes 1 divided by 25, an integral of 5 dt divided by 2 1 plus t squared. This is equal to 1 divided by 10 integral of dt of 1 plus t squared, which is 1 over 10 arcus tan of t plus c, which is then equal to 1 over 10 arcus tan of 2x divided by 5 plus c. Problem number 75 on our list is an integral of cosine x dx divided by 4 plus sine squared of x. Area in which this integral is defined is for all x's which are real numbers. By introducing the substitution that t is equal to a sine of x, we get that the differential of t is cosine x dx, and this integral can be solved. This integral then becomes differential of t divided by 4 plus t squared. 1 divided by 4 can be placed outside of the integral, and then it becomes dt divided by 1 plus t half squared. This is equal to 1 half of the integral of du divided by 1 plus u squared, where t half is equal to u is a new substitution. 1 half of dt is then equal to du. This integral then becomes 1 half of arcus tangens of u plus c. This is then equal to, when we return the substitution, to 1 half arcus tan of t half plus c. And when we return this into the x world, we get 1 half of arcus tan of sin x divided by 2 plus c. Integral number 76 on our list is an integral of sin x dx divided by a squared plus cosine squared of x. Now for a, which is equal to 0, this integral becomes an integral of sin x dx divided by cosine squared of x. This integral can be solved using a substitution that t is equal to a cosine of x, and the dt is then equal to negative sine of x dx. So this integral is then equal to negative dt divided by t squared, which is equal to negative integral of t to the power negative 2 dt, which is equal to negative t to the power minus 2 plus 1 divided by negative 1 plus an arbitrary constant c, which is then equal to 1 divided by t plus c. When we return the substitution, we get 1 divided by cosine x plus c. Area in which this integral is defined is for cosine x different than 0, and that means that x has to be different from p half plus kp, where k is an integer. And that makes area in which this integral is defined a set of real numbers without the dots p½ plus kp, where k is an integer. Now for a, which is different than 0, the area in which the integral is then defined is for all x's which are real numbers, and integral sin x dx divided by a squared plus cosine squared of x then can be written as an integral of negative dt divided by a squared plus t squared, again using the substitution that t is equal to cosine x and dt is negative sine of x dx. This integral is then equal to negative 1 divided by a squared of the integral dt divided by 1 plus t divided by a squared. By using the substitution that s is equal to t divided by a, we get that ds is 1 divided by a differential of t, and the integral can then be written as negative 1 over a, an integral of ds divided by 1 plus s squared, which is equal negative 1 divided by a arcostan of s plus an arbitrary constant c. When we return from the s world into the t world, we get minus 1 divided by a arcostan of t divided by a plus c, which is then equal to negative 1 divided by a arcostan of cosine x divided by a plus c when we return into the x world. Integral number 77 on our list is an integral of e to the power x dx divided by 1 plus e to the power 2x. We can introduce the substitution that t is equal e to the power x and then differential of t is equal to e to the power x dx. This is then equal to an integral of dt divided by 1 plus t squared, which is equal to arcostan of t plus an arbitrary constant c. And when we return into the x world, we get arcostan of e to the power x plus c. Now, area in which this integral is defined is for all x's which are real numbers. Problem number 78 on our list is an integral of dx divided by x times 1 plus ln squared of x. Now this integral is defined for x different than 0 and 1 plus ln squared of x different than 0 and x larger than 0. So ln squared of x has to be different than negative 1 and ln squared of x is larger or equal to 0, so this never happens. The area in which this integral is defined then becomes all x's which are strictly larger than 0. We can solve this integral by introducing the substitution that t is equal to ln of x, and that means that the differential of t is equal to 1 divided by x dx. This integral using the substitution then becomes an integral of dt divided by 1 plus t squared, which is equal to arcostan of t plus an arbitrary constant c. And when we return into the x world, we get arcostan of ln x plus an arbitrary constant c. Problem number 79 on our list is an integral of dx divided by a square root of 25 minus 9x squared. Now, area in which this integral is defined is for 25 minus 9x squared to be strictly larger than 0. That means that 25 is strictly larger than 9x squared, and that means that 25 over 9 is strictly larger than x squared. So minus 5 over 3 has to be smaller than x, and that has to be smaller than 5 over 3. So area in which our integral is defined is an open interval from negative 5 over 3 to positive 5 over 3. This integral can be written as an integral of dx over a square root 25, and in brackets we can write 1 minus 9 divided by 25 x squared. We can then transform this integral into 1 divided by 5, integral of dx divided by a square root of 1 minus 3x divided by 5, and that entire part squared. We can now use a substitution that t is equal to 3x divided by 5, and that means that the differential of t is equal to 3 over 5 differentials of x. Then our integral becomes 1 divided by 5 times 5 divided by 3, integral of dt divided by a square root of 1 minus t squared. This is then equal to 5 and 5 can cancel out, 1/3 of arcus sin of t plus an arbitrary constant c. And when we return into the x world, we get 1 over 3 arcus sine of 3x divided by 5 plus c. Problem number 80 on our list is an integral of 7 dx divided by a square root of 3 minus 5x squared. In order for this integral to be defined, 3 minus 5x squared has to be strictly larger than 0. That means that 3 is strictly larger than 5x squared, and that means that 3 over 5 has to be larger than x squared. That means that x has to be inside the interval from negative square root of 3 over 5 to the positive square root of 3 over 5. Now this integral can be written as a 7 divided by a square root of 3, integral of dx divided by a square root of 1 minus a square root of 5 over 3x squared. We can now introduce a substitution t, that t is equal to a square root of 5 over 3x, and then we get that differential of t is equal to a square root of 5 over 3 dx. Well, that makes dx to be a square root of 3 over 5 differential of t. This integral is then equal to 7 over a square root of 3 times a square root of 3 over a square root of 5 integral of dt over a square root of 1 minus t squared. This is then equal, square root of 3 is going to cancel out, to 7 divided by a square root of 5 times an arcus sin of t plus an arbitrary constant c, which is equal to 7 divided by a square root of 5 arcus sin. When we return the substitution, square root of 5 over 3x plus c. Integral number 81 on our list is an integral of dz divided by a square root of 9 minus 16z squared. 9 minus 16z squared has to be strictly larger than 0. 9 is larger than 16z squared, and 9 divided by 16 is larger than z squared. That means that negative 3/4 is smaller than z, and that is smaller than 3/4. This is area in which our integral is defined. So this integral can be written as an integral of dz divided by, we can take 3 outside of the square root, and the square root then transforms into 1 minus 16 is 4 divided by 3 z, and that entire part is squared. We can now introduce a substitution that t is equal to 4/3 of z, and then differential of t is equal to 4/3 of differential of z. Differential of z is then equal to 3/4 of the differential of t, and our integral becomes 1/3 times an integral dz is dt, and 3/4 of that, and in the denominator we have a square root of 1 minus t squared. This is then equal to 1/4 of arcus sine of t plus an arbitrary constant c, which is equal to 1/4 of arcus sine of 4/3 of z plus c. Problem number 82 on our list is an integral of cosine x dx divided by a square root of a squared minus a sine squared of x. Now, in order for this integral to be well defined, a squared minus a sine squared of x has to be strictly larger than 0, which means that a squared is strictly larger than sine squared of x, which means that negative a is smaller than sine of x, and that is smaller than a. Well, area in which this integral is defined then has to be for a under the absolute value to be larger than 0 and negative a smaller than sine of x, and that smaller than a. By introducing the substitution that t is equal to a sine of x, we get that the differential of t is equal to a cosine x dx. This integral is then, using the substitution, transformed into an integral of dt over a square root of a squared minus t squared. This is then equal to 1 over the absolute value of a times an integral of dt divided by a square root of 1 minus t over a squared. Using the substitution that t over a is equal to u, we get that 1 over a du dt has to be equal to du. Well, then this integral transforms into 1 over the absolute value of a times a integral du over a square root of 1 minus t over a, that is u squared. This is then equal a over a under the absolute value is just a sine of a times an integral of du divided by a square root of 1 minus u squared. This is then equal to signum of a times arcus sine of u plus an arbitrary constant c, which is equal to a signum of a times arcus sine of u was t over a plus c. This is then equal to signum of a times arcus sine of x divided by a plus c. Problem number 83 on our list is an integral of 3 to the power x dx divided by a square root of 25 minus 9 to the power x. Area in which this integral is defined is for 25 minus 9 to the power x strictly larger than 0. 25 then has to be larger than 9 to the power x, and 5 squared is larger than 3 to the power 2x. Well, that makes 5 larger than 3 to the power x. Well, that means that log for the base of 5 is strictly larger than log of the base 5 from 3 to the power x. Well, that makes 1 to be larger than log to the base 5 of 3 to the power x, which is equal to x times log of the base 5 of 3. Well, that means that 1 divided by log for the base 5 of 3 has to be strictly larger than x, and that means that log for the base 3 of number 5 has to be larger than x. Now this integral is equal to an integral of 3 to the power x dx divided by a square root of 25. In brackets we have 1 minus 9 to the power x divided by 25. This is then equal to an integral of 3 to the power x dx divided by 5 square root of 1 minus 3 to the power x divided by 5, and then the entire thing squared. This is then equal to, we can introduce a substitution that t is equal to 3 to the power x divided by 5, and that means that dt is then equal to 1/5 of 3 to the power x ln of 3. Now this is equal to 5 times 1 divided by ln 3 integral of 1 over 5 ln of 3 times 3 to the power x dx divided by 5 under the square root we have 1 minus 3 to the power x divided by 5 squared. This is then equal to 5 divided by ln of 3, an integral of dt divided by 5 square root of 1 minus t squared. This is then equal to 1 divided by ln 3 integral of dt over a square root of 1 minus t squared, which is equal to 1 divided by ln 3 arcus sine of t plus c, and when we return the substitution we get 1 divided by ln 3 of arcus sine of 3 to the power x divided by 5 and plus an arbitrary constant c. Problem number 84 is an integral of e to the power x dx divided by a square root of 1 minus e to the power 2x. We can introduce the substitution that t is equal e to the power x, and then differential of t is equal to e to the power x dx. This integral is then transformed into dt divided by a square root of 1 minus t squared. This is then equal to arcus sine of t plus c, which is equal to arcus sine of e to the power x plus c. 1 minus e to the power 2x is larger than 0, and then our integral is well defined. That means that 1 has to be larger than e to the power 2x, and that means that ln of 1 has to be larger than ln of e to the power 2x, which is only 2x times ln of e, which is equal to 1, thus making it 2x. That means that 0 is larger than 2x, and that means that 0 is larger than x. Well, that means that area in which this integral is defined is for all x's which are smaller than 0. Integral number 85 on our list is an integral of dz divided by z times a square root of 1 minus ln squared of z. Area in which this integral is defined is for all z's different than 0, and 1 minus ln squared of z has to be strictly larger than 0. That means that 1 is strictly larger than ln squared of z, and that means that ln of z has to be between 1 and negative 1. That means that e to the power negative 1 is smaller than e to the power ln of z, which is smaller from e to the power 1. That means that 1 over e is smaller than z, and that has to be smaller than e. Area in which this integral is defined is for all z's which are from the interval from 1 over e to e. We can introduce a substitution that t is equal to ln z, and that means that differential of t is equal to 1 over z differential of z. This integral is then transformed into an integral of dt over a square root of 1 minus t squared. This is equal to arcus sine of t plus c, which is equal to arcus sine of ln z plus c. Problem number 86 is an integral of dx divided by x times the square root of x squared minus 1. This integral is defined for all x's which are different than 0, and x squared minus 1 has to be strictly larger than 0. That means that x squared is larger than 1, and that means that x has to be larger than 1, or x has to be smaller than a negative 1. Area in which this integral is defined is an interval from negative infinity to negative 1 union an interval from 1 to positive infinity. Now this integral can be solved using a substitution that x is equal to 1 divided by t, and that means that dx is equal to negative 1 divided by t squared dt. This integral is then transformed into an integral of negative 1 divided by t squared dt divided by 1 over t times the square root of 1 divided by t squared minus 1, which is equal to negative integral of dt divided by t a square root of 1 minus t squared divided by t squared. This is then equal to a negative integral of dt divided by t times 1 divided by an absolute value of t times a square root of 1 minus t squared, which is then equal to negative signum of t times an integral of dt divided by a square root of 1 minus t squared. This is equal to negative signum of t times arcus sinus of t plus an arbitrary constant c. When we return the substitution, we get negative signum of 1 divided by x times arcus sin of 1 divided by x plus c. Integral number 87 on our list is an integral of e to the power ax plus b dx. Area in which this integral is defined is for all x's which are real numbers. This integral is equal to an integral of e to the power ax times an integral to the power b dx. This is then equal to e to the power b times an integral of e to the power a then to the power x dx. This is then equal to e to the power b times, well, an integral of a to the power x dx is equal to a to the power x divided by ln a plus an arbitrary constant c. This is the rule which we are going to use right here. So we get e to the power b times e to the power ax divided by ln of e to the power a plus c, which is then equal to e to the power b times 1 divided by a times e to the power ax plus a constant c, which is equal to 1 divided by a times e to the power ax plus b plus a constant c. Problem number 88 is an integral of e to the power x divided by e to the power x plus 1 dx. This integral is defined for all x's which are real numbers, and it is equal to an integral. Well, we can introduce the substitution that t is equal e to the power x, and then e to the power x dx is equal to differential of t. Well, that means that e to the power x dx is dt over e to the power x plus 1 is t plus 1. Well, this is then equal by introducing the substitution that t plus 1 is equal to u. We get that the differential of t is equal to the differential of u. So we get an integral of du divided by u, which is an ln of absolute value of u plus c, which is equal to ln of absolute value of t plus 1 plus c, which is equal to ln of the absolute value of e to the power x plus 1 plus c. E to the power x plus 1 is always positive, so we get ln of e to the power x plus 1 and plus c. Problem number 89 on our list is an integral of e to the power negative x squared dx. X dx. Now, area in which this integral is defined is for all x's which are real numbers. We can introduce the substitution that negative x squared is equal to z, and then we get that minus 2x dx is equal to differential of z. Well, that means that x dx is equal to negative 1/2 of the differential of z. So our integral then becomes negative 1/2 of the integral e to the power z dz, which is equal to negative 1/2 of e to the power z plus an arbitrary constant c, which is equal to negative 1/2 times e to the power of negative x squared plus c. Problem number 90 on our list is an integral of e to the power 2x dx divided by 1 minus 3e to the power 2x. Well, 1 minus 3e to the power 2x has to be different than 0, and that means that 3e to the power 2x has to be different than 0, which makes e to the power 2x different from 1/3. Well, that means that 2x has to be different from ln of 1/3, which is equal to ln of 3 to the power 1, which is equal to negative ln of 3. Well, x then has to be different from negative 1/2 ln of 3. Area in which this integral is defined is for all real numbers except the number negative 1/2 times ln of 3. What we can do now to solve this integral is to introduce a substitution that t is equal to e to the power 2x. That means that the differential of t is equal to 2 times e to the power 2x dx. We get that this integral which we started from is now equal to 1/2 the integral of differential of t divided by 1 minus 3t. We can now introduce a substitution that u is equal to 1 minus 3t, and then we get that du is equal to negative 3 dt. This integral is then equal to 1/2 times an integral of negative 1/3 du divided by u, which is equal to negative 1/6 ln of the absolute value of u plus c, which is equal to negative 1/6 ln of 1 minus 3t and plus a constant c. When we return this into the x world, we get negative 1 divided by 6 ln of the absolute value 1 minus 3e to the power 2x plus c. Integral number 91 on our list is an integral of e to the power negative x cubed times x squared dx. Area in which this integral is defined is for all x's which are real numbers. We can introduce the substitution that minus x cubed is equal to t, and we get that negative 3x squared dx is equal to differential of t. X squared dx is then equal to negative 1 over 3 differential of t. This integral then becomes equal to negative 1/3 of the integral e to the power t dt, which is equal to negative 1/3 e to the power t plus c, which is equal to negative 1/3 times e to the power negative x cubed plus c. Integral number 92 on our list is an integral of e to the power square root of x divided by a square root of x dx. The area where this integral is defined is for all x's which are strictly larger than 0. We can introduce the substitution that square root of x is equal to t, and then we get that 1 divided by 2 square roots of x dx is equal to a differential of t. Well, that means that dx divided by a square root of x is equal to 2 differentials of t. This integral is then transformed into an integral 2 times differential of t times e to the power t. Well, this is then equal to 2 times e to the power t plus c, which is equal to 2 times e to the power square root of x plus c. Integral number 93 on our list is an integral of 3 to the power 5x squared times x differential of x. Now, area in which this integral is defined is for all x's which are real numbers. This integral can be solved using a substitution that 5x squared is equal to t, and that means that 10x dx is equal to dt. X dx is then equal to 1 over 10 differential of t. This is then equal to 1 over 10 integral 3 to the power t differential of t, which is equal to 1 over 10 times 3 to the power t divide by ln of 3 plus c, which is then equal to 1 over 10 ln of 3 times 3 to the power 5x squared plus c. Integral number 94 is an integral of a to the power 2x times b to the power 2x dx. Now, area in which this integral is defined is for all a's which are positive numbers, b's which are positive numbers, and x can be any real number. This integral can be written as an integral of a times b, and then the entire product on the power of 2x dx. This is then equal to, we can introduce the substitution that t is equal to 2x, and then we get that the differential of t is equal to 2 differentials of x, which makes differential of x be equal to 1/2 of the differential of t. So our integral is transformed into 1/2 of the integral ab product to the power t times differential of t, which is equal to 1/2 times EAB to the power t divided by ln of the product AB plus an arbitrary constant c. That is equal to 1/2 times AB product to the power 2x divided by ln of the product AB and plus c. Problem 95 on our list is an integral of a to the power x to the power 4 times x cubed dx. This integral is defined for all a's which are positive numbers and x can be any real number. This integral can be solved by using the substitution that t is equal to x to the power 4 and then differential of t is equal to 4x cubed differential of x. X cubed differential of x is then equal to 1/4 of the differential of t. So this integral gets transformed into 1/4 of the integral a to the power t times differential of t, which is equal to 1/4 of a to the power t divided by ln of a plus c, which is then equal to 1/4 times a to the power x to the power 4 divided by ln of x to the power 4 plus a constant c. This is then equal to, this is ln of a. So the solution is just 1/4 times a to the power x to the power 4 divided by ln of a plus c. Integral number 96 on our list is an integral of e to the power square root of x times a differential of x divided by a square root of x. We can solve this integral by introducing the substitution that square root of x is equal to t, and that means that 1 divided by 2 square roots of x dx is equal to differential of t. Well, area in which this integral is defined is for all x's which are larger than 0, and this integral gets transformed into two integrals of e to the power t dt, which is equal to 2e to the power t plus a constant c, which is equal to 2 times e to the power square root of x plus c. Problem 97 is an integral of e to the power sine of x cosine of x dx. Now this integral is defined for all x's which are real numbers, and it can be solved by using the substitution that t is equal to a sine of x, which makes differential of t to be cosine of x dx. This integral is then transformed into e to the power t times dt, which is equal to e to the power t plus an arbitrary constant c, which is equal to e to the power sine of x plus c. Problem 98 is an integral of 1 divided by x squared times e to the power 1 divided by x dx. This integral is defined for all x's which are different than 0, and it can be solved by using the substitution that t is equal 1 over x. That means that the differential of t is negative 1 over x squared dx, which means that 1 over x squared dx is equal to negative differential of t. This integral then becomes an integral of negative integral of differential of t times e to the power t. This is then equal to negative e to the power t plus c, which is negative e to the power 1 over x plus c. Problem 99 on our list is an integral of ln cubed of x divided by x dx. Well, area in which this integral is defined is for all x's which are larger than 0. We can introduce the substitution that t is equal to ln of x, and that means that the differential of t is equal to 1 over x differential of x, and our integral then becomes t cubed times differential of t, which is equal to t to the power 4 divided by 4 plus c, which is equal to ln to the power 4 of x over 4 plus c. And finally, problem 100 on our list is an integral of ln y divided by y differential of y. Area in which this integral is defined is for all y's which are strictly larger than 0. We can introduce the substitution that t is equal to ln of y, and that means differential of t is equal to 1 divided by y differential of y. Integral is then transformed into an integral of t differential of t, which is equal to t squared divided by 2 plus c, and that is 1/2 of the ln squared of y plus c. If you are interested in more integrals, I suggest that you watch this video next. In it, I have gone through all the methods and substitutions which are used for solving integrals. Thank you for watching this video. Please like, share and subscribe, and I am looking forward to reading your comments.